You know that magic number on your phone, the estimated time of arrival. It tells you if you're going to make your flight or when your pizza's showing up. But have you ever stopped to think about what's really going on behind that number? Turns out it's not just simple math. It's a fascinating scientific battlefield.
I mean, just think about it. It is the absolute heartbeat of modern life. Google Maps, Waze, Uber, DoorDash, all of these services we use every single day, they all depend on one thing: accurately predicting when someone or something is going to arrive. A huge part of our economy is built on this one little number.
So you look at your screen and you see it. 23 minutes. Seems so simple, right? So confident. But how? How in the world does your phone know about that traffic jam 3 miles ahead? Or that you're about to hit a whole series of red lights? And that is the big question we're tackling today. Because for years, the super smart people behind these apps have been locked in this quiet but really intense debate over the absolute best way to solve this very problem. And it's a debate with two very, very different answers. So let's get into it. There are basically two main schools of thought here. A great way to think about them is like two different recipes for cooking up your ETA. Both are trying to get to the same delicious result, a super accurate arrival time. But their methods for getting there are just fundamentally different. All right, first up, we have the segment-based method. This approach is all about the tiny details. It breaks your entire trip down into little bitty pieces, or road segments, like the stretch of road from one intersection to the next. Then it predicts how long it'll take you to travel each individual piece, and at the very end, it just adds them all up. Simple enough, right? And the second recipe? That's the route-based method. This one takes a completely different, much bigger picture view. Instead of looking at all the little pieces, it looks for entire trips from the past that were a lot like yours, trips that started around the same place and ended around the same place. It then uses the total travel time from those past journeys to predict yours. And this is where it gets really interesting, because there's a big trade-off. This segment-based method, the one with all the little pieces, has a massive advantage. There's just tons of data for every little bit of road. But its big weakness? A tiny error on each piece can stack up and become one giant error by the time you reach your destination. And the route-based method is the exact opposite. It might not have a lot of data for your specific A to B trip, but it's great at absorbing those little hiccups between segments. For years, different studies came to opposite conclusions, leaving everyone kind of scratching their heads about which one was actually better. And that brings us to our source material, a 2023 paper from some brilliant researchers. They decided to just cut through all the noise, all the messy and contradictory real-world studies, and just solve this debate once and for all. Here's the key thing about their approach. They didn't just run another test drive. No, they built a powerful mathematical model. This let them analyze the pure, fundamental statistical efficiency of each method. They stripped away all the real-world chaos to see which one was just inherently, provably more accurate. So, after all the debate, all the conflicting studies, and this new head-to-head theoretical battle, who came out on top? Which recipe for predicting your arrival is fundamentally better? Well, the paper's conclusion is honestly crystal clear. They found that, quote, maintaining a segment-level architecture is often of first-order importance. Now, in the world of academic research, that's about as strong a statement as you can possibly make. It's a knockout. So, to put it simply, this segment-based approach wins. That huge advantage of having so much data for every individual piece of the journey, it almost always outweighs the risk of those small errors adding up. The little details really do matter the most. And the results really speak for themselves. When they ran the numbers in their model, the prediction error for the segment-based method was consistently and significantly lower than for the route-based one. We're not talking about a small difference here. It's a fundamental advantage in accuracy. But, and this is a really important but, it's not always the winner. The paper points out this fascinating rare exception. The route-based method can actually be more accurate when travel times on different segments are what's called negatively correlated. The perfect example is a city with synchronized traffic lights. You know how a long wait at one red light often means you're guaranteed to catch a green light at the next one? In that specific case, the route-based method is actually better at seeing the whole picture and absorbing that variability. Okay, so this is all pretty cool academic stuff, but why should you actually care? How does this theoretical showdown end up affecting your daily commute? Let's connect the dots.
Well, before this paper, companies had to kind of guess which method was better or try to blend them together. This research gives services like Google Maps and Waze a clear roadmap. It gives them the confidence to know that focusing on those small, granular road segments is the right way to go. And that means the ETAs you rely on every single day are just going to keep getting better, more accurate, and more reliable.
And that leaves us with one last big question. We've managed to build these incredible models that can predict the chaotic, unbelievably complex flow of millions of people through a city with stunning accuracy. Now that we're getting this good at predicting traffic, what's the next complex system we're going to predict? Weather? The stock market? The future of prediction is really just getting started.